Ladies and gentlemen, would you please welcome Andy Palay.
Good morning. My name is Andy Palay. I'm a gears developer, or as I saw on the web, a gearhead, which I guess is better than when I grew up, which was I was a cheesehead from Wisconsin. I'm joined here by Mike Zhao, another gears engineer, who's one of what I would claim is one of my partners in crime. So what's the crime? Crime is very simple. We started this project and looked at what to do about making web applications better. Web applications, needless to say, are very near and dear to Google's heart, near and dear to lots of people out on the web. And we had a very simple thing that we came up with. The crime, making the web work without being connected to the web. That's what we've been up to. That's what Google Gears is trying to do. It's trying to provide a better application space, and the major problem with respect to Google applications and other AJAX applications is you have to be connected in order to use them. So if we could get the connection to the machine. There we go. So, interesting question that's been posed. This has been posed on the web recently, which is a very simple question. Are we too late? Does this make sense? The world is becoming more and more connected. You can hardly go anywhere and not have an internet connection, or so the claim is. The problem with that is that users don't like the notion of, well, I'm almost always connected. I want to have my data when I want my data, not at a point in time when I might be connected. So reliability, especially reliability of network connections, is very important. I don't know how many of you have traveled here. If you've traveled here, you might be staying at a hotel that provides internet connectivity. If it's like any hotel that I've been at that provides internet connectivity, there's about a 50% chance that the connection in your room is going to work, regardless of how much they're going to charge you for it. It's just not reliable. Okay? That level of reliability brings people to say, I want my data on my machine. That means you move away from web applications. Convenience is another key piece of it. Again, you go to the hotel. Okay? You want to look up something very quickly. Somebody sent you an address in your email. Okay? Fortunately, you didn't print it out. You didn't save it anywhere else on your machine. You need to go there. You get into your room, you connect, and what do you see? You see this wonderful screen inviting you to register, possibly give them your credit card. 5 minutes later, you might have a connection. I don't want to worry about paying the cost. I don't want to worry about taking the time. I just want my data. Again, brings it back to the local machine. It turns out the other thing that we sort of looked at was a realization that you're actually offline much more often than you think you are. Now, that might seem a little weird, especially if you use a desktop machine. I will agree, desktop users know when they're online and when they're offline. Laptop users, however, just discount lots of amount of time that they're offline. I have a daughter who lives in Los Angeles. I travel by car every so often. I'm not driving when I'm doing this, mind you. Okay? I don't worry about being connected. 5 hours of time, I know I have no connectivity. Therefore, any web applications I might be using, I'm just not going to use them. And that doesn't register in my mind as I might be disconnected. Now, some of you might say that's a good thing. because at least for 5 hours, I'm actually not connected to the internet, but I have work I want to do. And so what I have to do is remember, well, I have to get it off the network, out of the cloud, and bring it onto my local machine if I want to actually use it. And I might not know which data I actually want. Now, even if the world became completely connected, there's another problem, which is performance. You have web applications. Okay? They don't perform as well as desktop applications because whenever you're dealing with the data, you're making this round trip to the server and back. Take your favorite mail program. Hope it's Gmail, but your favorite mail program. Okay? Every time you open it up, you have to fetch all the messages, or at least the headers for the messages. That takes time. Okay? As you saw in the earlier demo with Reader, when the data is offline, is blindingly fast. Why? You don't have to worry about the network round trip. So we decided it was really worth the bother. Next slide. So we started working on it. Okay? Google Gears, as was mentioned earlier, this is an early release. It's an early release because we learned a whole bunch by looking at what it would take, what we would need to do to take Google's applications and have them work offline. What we wanted to do was find out and get the expertise of everybody else of what it's going to take to get everybody else's applications to work offline. Here's a list of some of the things that we've learned. My guess is we'll learn some more as more of you start using this. First one, we wanted to build off of what was going on, the way web applications worked. So we really wanted to continue the notion of there's one application you're going to use. There's one URL you go to. You don't come along and say, well, let's see, if I want to use my mail program and I'm connected, I have this URL to go to. And if I'm going to use it when I'm disconnected, I go to this URL. Okay? Because actually the second problem, which is it turns out you move from being online and offline very rapidly these days. Network connection drops. We also wanted to make sure that, unlike desktop applications, where you have a desktop application and you have a web application, you now have two different interfaces. One of the nice features of web applications is no matter what browser you go to, no matter what machine you go to, no matter how you're using it, you always get the same interface. We wanted to make that interface better by allowing you to deal with information offline, by allowing the speed, the performance to be optimized. But we didn't want to change the experience in order for you to gain those benefits. So one application, one URL. Again, there's a seamless transition from being online and offline. How do I go offline? Okay? I sit at my desk. I have Reader installed. I have the ability to go online and offline. Ideally, the way I normally go offline is I pick up my machine, I disconnect, and I walk away. Now, Reader actually is an early version. We wanted to have it out there as a way to show people what the power of Gears is. But even it is not complete. Okay? It has a step, as was shown earlier, which I have to say I want to go offline. Okay? There's no time I want to go offline. I just go offline. If I'm on a train, if I'm on a bus which has wireless, okay? Lots of Googlers understand, we have buses that bring people in, have wireless. Okay? Unfortunately, that wireless goes up and down. Okay? It's the reality of the world today. Okay? You don't want the user to have to worry about switching back and forth between being online and offline and online. One, it will drive them nuts as the network bounces up and down. The second one is that you'll forget. You'll be offline, you'll walk into the office, you'll connect the network, and you'll stay offline because you forgot to flip the switch. The user should not be the person, ideally, again, in a perfect world, being the one who's synchronizing or deciding when to go online and offline. That should happen in the background. Again, with respect to performance, once you get the data onto the local machine, we might as well use it. Okay? Now, not every application is going to have all the data that the user might want to see. Example for Reader is Reader right now handles the last 2,000 feeds. If you want more than 2,000 feeds, it's fine to go on the network. As an application developer, the notion was the developer should be able to decide how much data is reasonable to bring onto the user's local machine. Could be all of it if it's small. Could be just the most important information if it's exceptionally large. And finally, it has to be available on all platforms. A single browser solution isn't good enough. Okay? Users use lots of different browsers. Developers want to know that it's available everywhere. Okay? And the only way to do that is make it on single browsers, or on all browsers. So what did we decide to do? We decided to take an approach which was, let's do just enough to make it work. There's a large spectrum of how you could actually solve this problem. Okay? We've looked at sort of what we've been doing, what lots of people have been doing, said, look, AJAX is working. It has limitations, but AJAX is working. But it's missing how to deal with offline. So our job was to do just enough. The way to look at this, and I believe Mike was the person who first coined this phrase, was to do for offline what XML HTTP requests did for web apps. XML HTTP request was a very small addition to the environment of the browser. And all of a sudden enabled an explosion of new web applications. What we wanted to do was have a take a similar approach, which was find the core that's necessary to enable offline and let the web applications take advantage of it. We've done this as an extension to the browser. We have it available today on IE and Firefox on all three Windows, Mac, and Linux. In the open source code, there's actually code for Safari. It actually works, okay, if you know how to build a version of Safari yourself in terms of WebKit. Okay, you'd be able to build it. Okay, the basic problem that we stayed away from is that it's not easy to install at this point. We're making it available as an open source, okay, with a license using the new BSD license, which essentially means it's yours to do with it whatever you wish. Okay? Now, our real goal in this, in terms of open source, is we want to work with partners, as you saw some of them up on the screen earlier, to take this and move it along and have it be a standard in the browser world. Okay? We chose to do this in terms of let's understand what we wanted to do, what we needed to do to sort of what we learned with respect to experimenting with Google applications, bring it out to other people, learn more. This is not a final API. This is under development. learn, and work through that process with other partners and the open source community. So, what do Gears applications look like? There's lots of things that go on, but the fundamental piece of this really amounts to bringing your data local to your machine. So you have the data local in a local store. Changes get made by the UI to that local data. When it wants to display information, it gets the data from that local store. The changes are queued up so they can be synchronized with the server. Whenever there's connectivity, the application synchronizes. That might occur all the time if you happen to be connected. Can't occur when you're disconnected. But when you reconnect, the data gets synchronized. Okay, both the data that you change going up to the server and the data that's changed on the server coming down to you. Now, there's a lot to do with respect to synchronization. Gears provides the basic tools to allow you to build that. We currently do not provide you tools to actually do, to guide you in synchronization. That's a hard problem. Okay? Hopefully, as this goes out, we might get ideas from people of how to actually provide a standard way to synchronize or to do conflict resolution. That's a hard problem to deal with, especially as you get large data sets. But the key thing for the application is you connect, you synchronize. When you are connected, you're always synchronizing. Next. Next slide. So a way to look at this, very simple AJAX architecture, probably way too simple, but easy way to describe it. You have a whole bunch of JavaScript code in the UI, interacting with the web pages, talking XHR off the internet. What happens when you build a Gears application or take your application and modify it to be a Gears application? Simplest form is you're introducing a local database in the middle. The UI interacts with that local database. The local database maintains enough information so that it can synchronize, another piece of code can synchronize that to the server. Another way to look at this is if you look at the traditional web patterns, the traffic patterns. This is original web applications. Every time the user did something, round trip to the server. Okay, very painful. Okay, don't know how many people remember sort of using mail programs, for example, that did that. With AJAX, the nice thing that occurred was not all the round trips had to go back to the server. Data could be maintained locally. Okay, in memory, basically the only place, unless it was really small, and then you could try to hide it in a cookie. Okay, but any real large operation actually had to go to the server. With Gears, basically everything stays local. Now it's a little bit not quite right because, again, if you don't have all the data local, some of it's going to go to the server. But the bulk of your operations stay local. Synchronization goes on completely in the background and completely detached from the user operations. The user gets the same feel as if they were using a normal desktop application. Next. So what do we need to do this? We basically developed 3 components, 3 modules to solve this problem. Local server. Clearly, if you're going to run an application when you're disconnected, you need the resources of that application on your machine. Now, the browser has a cache. Why not use that? As Othman's example sort of showed, he had to clear the cache. Sometimes it works. Problem is, and I'll get into a little bit more detail, sometimes it works, it doesn't work all the time. Okay, you want to be guaranteed that the application is actually there. That's what the local store is providing, local server is providing. Second one is a database. We want to be able to store large amounts of data. There's a whole bunch of different ways you could do this. We chose to actually build it on a real database because that gives you a great deal of power. And I'll get into a little bit more. And finally, third component is a worker pool. Okay, this allows you to perform long operations. What are the problems that exist with respect to a web application when you take the data and move it to the local machine? All of a sudden, computation that used to be done on the server ends up being done locally. Now, browsers, unfortunately, are mostly single-threaded from the user's perspective. Some better than others, depending on whether or not you fire up a new window and whether or not you're lucky enough for a new process to be started. But way too often, if a single web page starts doing a long JavaScript computation, the UI freezes, and you wait. Okay? This isn't acceptable from a user's perspective. It used to be hidden by the fact that all the computation was done on the server. And when you did that server round trip, the UI was freed up. Not the case when you start bringing computation locally. When that happens, you actually end up having to do the computation in a way that doesn't block the UI. And the way we did that was by providing what we refer to as the worker pool, which is a way to run JavaScript code outside of the main UI thread. So the local server. Again, its job is to run the application code offline. It has two types of caches, and we use the term offline caches with quotes. And the reason for it is, unlike normal caches, which are completely under the control of the browser, this cache is under the control of the application. The simplest of them is the resource store. This is where we started. Started with the resource store, and its job was to be able to capture individual URLs. Now, we determined it's still useful. Okay, it's useful, for example, if you have an application that has, for example, an attachment in mail, and you need to show it as an attachment, the only way to actually have it show up properly within the browser is if it's served as web content. And the way the local store works is it just basically intercepts URLs and says, OK, I have that locally, I'm going to serve it. From the browser, it appears just as if it came down as part of a normal HTTP request. It turns out the resource store isn't good enough for applications. Okay, there's something special about application code, which is you can't afford not to have all of the application. You can't afford to have one part of the application version 1, and half your application is version 2. So what does the managed resource store do? It's very simple. It provides you a way to describe your application. Your entire application as a list of resources and what we call as a manifest. Okay, it's just a URL, but it's a URL that gets passed to gears. And once it gets passed to gears, and I'll explain how momentarily, the application no longer worries about it. The application at that point, gears will capture it. It will update it atomically. Okay, so if you're running version 1.1 of the application and somebody posts version 1.2 on the website, it will capture 1.2. You actually won't know that it's doing it. Doesn't pop up a dialog box saying, do you want to update the application? Just as a normal web application, you get the latest thing. You no longer have to think about installation or updates. until it has captured all of 1.2, you will still continue to run 1.1. In fact, you'll continue to run 1.1 until you reload the page. Okay, so you always have a consistent version of the application. It also updates the application automatically. As I said, you don't have to think about it. Now, it says on each view, but as with any sort of browser, it doesn't do it quite on each view. It just wants to make sure that you have the latest thing. Once you have this data, you always run locally. Okay, you will never go off to the server in order to run that application. Why? Let's assume you went to the server. So you have 1.2 on your machine now. You start running, and unfortunately, 1.3 is up on the server. So you start getting some of the resources from 1.3. Then you pick up your laptop and go and leave. You're back again in the place where you have half of one version, half of the other. So data is served locally. The other thing the Managed Resource Store does is it provides a way to handle multiple users on the same basic desktop login. Unlike normal applications, you end up logging in with respect to a user. So if Mike has one set of preferences with respect to an application, I have another, and we happen to both be using the same machine, I want my version, Mike wants his. And the Managed Resource Store provides that. Managed Resource Store, we'll quickly go through the code. At the top, basically, is how you get a Gears module, in this case, a local server. Okay, you create the type of component, in this case, local server. The beta flag will go away whenever we decide with the community that we've moved beyond beta. Version has a major number and minor number. Major number would generally increase whenever an incompatible change is made. The minor number notes compatible changes. So you then create a managed store. You point to give it the manifest, and you say, check for updates. In fact, with respect to Gears, this is the only time, the first time that you actually have to say check for updates. After that, it is all automatic. The manifest file, very simple. It's a JSON formatted file, has a version. Okay, it's just a string. If it happens to go backwards, it's actually fine. It will pick up the new manifest and thus the new resources whenever the client's version is different than the server's. Why? So every so often, you release something that doesn't work right, and you want to roll it back. Because this is all handled by Gears, it will automatically get you the new version. So you'll never be in a position where you're stuck with an application that no longer works and you have to sort of dig around in the system to try to get rid of it. They roll back the version, you'll get the older version, you'll actually get moving from that point. So, demo time. The real answer to this is an offline Gears application. Okay? Could have been online, I could have captured it, but in fact, I'm paranoid. Okay? I did not want to trust network connectivity to here. Okay? Had no idea preparing for this whether or not we'd have good network connectivity. So before I left the office last night, I captured this application. Okay? The laptop has actually been running offline. Okay, and Mike goes in and goes to the top and sort of types in whatever his, okay? But yet the application, the Gears application is running. It is just somewhat, I would say, a normal web, has web pages, has JavaScript code, etc. It's just been captured, and we're able to run. So, the database. Local SQL storage, we looked around, we decided we wanted to use a database. We chose SQLite. Why? One is to match what we're trying to do, it's open source, freely available under very similar licensing. It's mature, it's small, it's fast, it's full function. Okay, or at least full function enough to satisfy most needs. Okay, not full function if you put it up against very high-end databases, but for most things that people use, it has it. Okay, and it's again very small. We wanted the footprint of Gears to be small. Even though it's small, it handles large amounts of data. Now, a question which gets posed with this is, what do you do about security? You're taking this data, putting it into a local database. How do you protect it? We've chosen a model which is a very strict same origin security model. The domain has to be the same, the protocol has to be the same, the port has to be the same. So two applications from two different sites cannot get to the same database, to each other's database. So the code for the database, again, you create the database using the factory. Now you basically have an interface which gives you the ability to write SQL statements. Okay? We've chosen not to try to develop something higher than that. Again, we wanted the most minimal interface we could. We'll leave it to other higher level toolkit providers to look at other abstractions. If those become useful and need to be part of Gears, and the community believes it is, they might migrate. But right now, very simple. You have a SQL interface. This case, the interesting thing about this is it's a parameterized SQL statement. The two question marks are replaced by the values in the array following it. Why? For security purposes. When you start dealing with SQL, typically this had occurred on the server, but now we're bringing it to the client, you have a problem which is called SQL injection, where people sort of create strings that they then add into the SQL statement that change fundamentally what the statement is doing. Parameterized SQL gets you around that problem. So you could have written this as with just concatenating burrito and 5 into those places, but this gives you complete protection. Second SQL statement is just doing a select and then doing a result set and iterating through the rows, displaying the name of the foods that you like, ordered by how much you like them. Very simple interface. Next. So, as I said, this is a Gears application. In fact, it's a very simple web page. There's one web page here, one HTML page. Okay, the HTML page has a bunch of slots, and the slots are filled in by data in the database. So if we go to the actual database, this is an application that we actually ship as is available as part of the download. So you can come in, you can look at the database. This is the list of all the points that were in the slides. Here's the list of titles. And we can even go in and update one of the titles. Okay. Now, if we go back to the application or to the talk, there's the new title. Okay. This, again, little Gears application comes with the rest of the download. It's a great way to actually be able to look at your data when you're developing. But if you don't like it, there's lots of other third-party SQLite tools that you can use. So now to the third component, the worker pool. The ability to run JavaScript in the background. Again, computation is coming to the local machine. Okay, you want to be able to run that without blocking the UI. We chose to do it by providing really a process model within JavaScript. Why do I say processes as opposed to threads? Okay. Processes in terms of they do not share memory. Why not? If you start trying to share things like the HTML DOM, all bets are off on whether or not your browser will even keep running. We chose a path which said, we want to provide you a way to do computation. First place it showed up turned out to be in synchronization. As I said, synchronization can be a difficult problem, takes a reasonable amount of computation, a reasonable amount of interaction with the local store. You don't want the application to block while you're synchronizing. So having a very simple message passing scheme, you create a worker, you pass messages to it, was enough. Enough to do real computation, enough to do synchronization, and remarkably nicely fit into the model of how JavaScript in the browser works today. The main JavaScript engine for a web page is event-driven. The event in a worker is a message from another worker. So the code, calculating the next prime, is the code that we're going to, in this example, would run in the worker thread, worker pool. We create a pool. We associate a message with it, or an on-message handler with it. So whenever the worker that you create sends a message, an alert will come up telling you what the next prime is. Then we create the worker, pass it a string. What actually gets passed in terms of starting a worker is the code to run. So the function plus the call to next prime. Now, to make this a little bit clearer what's going on, or to sort of show this, we went for a slightly harder problem, which is to find prime quadruplets. Okay? It's a little bit more inefficient, so we'll show off how the worker pool works. So in the first example, we're doing this in the foreground thread, in the normal browser thread. And as you notice, the wonderful progress meter, okay, is taking its time. And as Mike tries to select text, it sort of gets more and more painful. Okay? Not a very good user experience. Now, we'll run it in a worker pool. Progress meter keeps running smoothly. User interface continues to be responsive. And in fact, we can run another one. User experience doesn't change. Now, if you run 100 of them, it will probably change. So those are the three components. Now, given this is a Google talk, given this is a Google project, you can't do something without doing search. As part of this project, we decided we really needed to provide search, an essential part of lots and lots of different web applications. So we have an example of doing search. In this case, this is showing you all the pages that have the word database, or in fact, full text. And this is really a full text search. Okay, what did we do? We've been working with the SQLite community, with the SQLite developers, in a joint way, providing this as open source, to provide full text searching within SQLite. The current instantiation of this is called FTS2, Full Text Search 2. There was an original Full Text Search 1, just in case you wanted to know. Okay, Full Text Search 2, FTS2 handles millions of documents. Being Google, we don't believe that's good enough, so we've embarked on trying to extend this to be tens of millions of documents. The other thing that isn't there today is multilingual support in terms of search. Those will be coming. So the way this works is a new addition to SQLite was the creation of virtual tables. Using FTS2, you've basically created a table which has both columns, title, and content. Now, the interesting thing, where I used to have to basically do these crazy things, and if I wanted to search for both two different words, it gets really hairy in terms of the SQL context. I can now just do a very simple search. And in this case, actually, it has some built-in functions to return the snippet, the area around the document which had that word in it. The bottom part is actually just showing sometimes you actually have data that you want to use full text searching on or not. There are easy ways. It's just like any other table. You can do joins on these tables. You can insert and sort of keep them in sync. That's what we've done for full text searching. And it's available today as part of standard SQLite, even without getting gears. So for more information, as was said, there's a fireside chat, and I think given the time, I'm going to say it's time we'll head off to lunch. You can catch us in the lunchroom. We'll be off in a spot. It's marked on the map. There's a fireside chat if you have more detailed questions that you'd like to ask us. It's at 1 o'clock in, I think, room A1. There's another talk called Nuts and Bolts and Gears, which talks about higher level toolkits that give you access to gears. And you can actually get gears at that site. I thank you very much. We look forward to working with you as developers, both as people who want to build gears applications, also for people who want to help push this as a standard and help us develop it as a standard. So feel free to join in on the group at Google Groups. And the final one and most important one is, as far as I've been told, the ladies and gentlemen over there will be handing out T-shirts. So thank you very much.